Welcome back, friends, to the new session of our Serving One subject. Myself, Assistant Professor Nitish Mohite, working in the Department of Civil Engineering of Bharati Vidyapith's College of Engineering, Kolhapur. I have completed my master's degree in civil structures. So, in the today's session, we are going to deal with the next experiment, that is plane table surveying by radiation method. How it has been practically conducted. So the points that are going to be discussed by us today in this session are nothing but what are the prerequisites of plane table surveying, okay, by radiation method. That is what we should know before going to conduct the plane table surveying by radiation method. What are the instruments required? Correspondingly, how the field procedure of plane table surveying by radiation method is been carried out. Okay, moving further, starting with the first point, prerequisites of plane table surveying by radiation method. Okay, so prerequisites means what we should know what we are going to conduct initially, that is the concept of the radiation method. So basically in the plane table surveying by radiation method, here in the previous screen you might get an idea that we are going to keep the plane table here, okay, at a station point from which all these points A, B, C, D, E will be visible to us. Okay, so here you can see A, B, C, D, E are the points that are supposed to be bisected from a single station point. Okay, and we are going to draw the rays, measure the distance, and draw the sheet. That is nothing but the radiation method. So practically, when we are going to see the video, you will get an idea. Okay. So we are knowing that the principle of plane table is nothing but based on parallelism. So meaning of that is nothing but the rays which are drawn from the stations to the objects on the paper are parallel to the lines from the stations to the objects on the ground. Okay, so that is nothing but the principle of plane table. So now in the case of this radiation method, okay, so this basically radiation method is been suitable for locating the objects from a single station. Okay, so in which correspondingly the rays are being drawn from the station to the object, and the distances are being measured from the station to the objects. They are being converted to suitable scale along the respective rays, and correspondingly the sheet is been drawn. Okay, so moving to the next point, that is what are the instruments that are required. So plane table with tripod stand, as you can see here, plane table is okay, here it is a plane table which has been mounted on a tripod stand. Then ranging rod we require for bisecting the object, then arrow for correspondingly marking the station point O on the ground, then measuring tape for measuring the distances from the station to the object, then alidade. So here you can see this is nothing but the alidade for bisecting the objects, on which on one side it is eyesight and second one is the object when spirit level is requiring for, this is nothing but the spirit level which is required for leveling the plane table. U4 with plumb bob, so which is required for marking the center point of the ground or transferring the ground station point on the drawing sheet. Okay, and trough compass. So the use of this trough compass is nothing but marking the north direction at the top right hand corner of the drawing sheet. Okay, so these are the instruments that are requiring. Along with this, we require the drawing sheet, then drawing material, likewise pencil, eraser, small scale, okay, etc. Okay, clamps also for fixing the, or you can make use of the sellotape in order to fix up the drawing sheet over the plane table. Okay, so in this case, we are requiring the full imperial size sheet. Okay, so now we'll move to the field procedure of plane table surveying by radiation method. Okay, so basically, we are going to first of all mark the station points. Okay, okay, the correspondingly A, B, C, D points, whichever are the points on the ground which are supposed to be bisected, that is object points, not stations. Okay, so here is the B point. So initially it was A point. Okay, here is the A point. Okay, that has been marked. Okay, then next one is the point C. Okay, here is the point C object. Next, here is the point D. I'm going to mark it. Okay, so which I'm supposed to bisect it. And okay, and finally, here is the point E, which I'm going to bisect it. Okay, so here we have marked 5 points starting with A, B, C, D, E. So this was the last point. Okay, now what we are going to do? We are going to see the all points. So they are been visible from a single station point. So this is the A point. Okay, here you can see. So this is nothing but the B point. Here is the point C. Here is the point D, where we are marked, and correspondingly this is the point E. Okay, so now we are going to select a particular station from a station point from which all these points, 5 points, will be visible to us. So I'm going to mark the point on the ground and insert the arrow. Okay, so that will be nothing but my station point O. So here you can see, so this is nothing but my station point O. Okay, next I am going to open the tripod stand and correspondingly keep it over the station point O and fix up the plane table over the top of it. Okay, so I'm adjusting as we usually do in case of when we are handling the dumpy level or auto level, so that it is at equal level all the three legs. Okay, then we are going to spread all the three legs and keep it over the station point O. Okay, so here we can see we are going to fix up the plane table over the tripod stand with the help of the wing nut, which is provided in order to fix it over the tripod stand. Okay, got it. So when it has been fixed, okay, then we are going to do the temporary adjustment of plane table. Okay, So as you can see here, it is not leveled. Okay. So regularly by keeping the two legs firm in the ground, I'm going to just move the third leg inside outside in clockwise anti-clockwise direction. Okay. So and bring approximately, I'm going to check it. Okay. So as the surface is a greater one as compared to other instruments. So basically I'm going to keep the drawing table, drawing sheet on the correspondingly plane table. Okay. Clamp width. Okay. And correspondingly we are going to do the leveling operation. Okay, got it. Then we are going to do the we are going to do the transfer of the station point of the ground on the drawing sheet with the help of U fork. So you can see here the U fork is been just been released with the plumb bob, and correspondingly it is supposed to be transferred. Okay, so here is the ground point. Plumb bob has been released from the bottom point of the wing nut, and it is supposed to be transferred over the point. Okay, drawing sheet. So I'm going to mark a point O here and place a pin here, so that it will be nothing but the station point. Okay, so I marked the station point O here. Now, after correspondingly transferring the ground point on the sheet, okay, I'm going to do the leveling operation with the help of this spirit level. Okay, here you can see as the bubble is not at the center. Okay, so we are going to do the leveling operation. Okay, so usually we keep all the this spirit level at each corner and adjust it. Okay, so that I can land finally at the center. Okay, so whenever it is at the center, okay, we are going to start the process. Okay, that is doing the bisection. Got it? So by correspondingly making use of the tripod leg, we are going to bring the bubble at the center of its run. Okay, so at the time correspondingly doing the leveling operation, we are going to keep the U fork. You can see it here. I'm going to keep the U fork here, so that correspondingly centering and leveling operation is to be carried out simultaneously. Okay, and finally we are going to check it when the bubble is at the center. So here you can see the bubble is at the center of its run. Okay, so now after the bubble is at the center, we are going to correspondingly mark the north line at the top right hand corner with the help of the trough compass. Okay, so here you can see I have kept the trough compass at the top right hand corner of the drawing sheet. Okay, and by losing the wing nut, okay, I am marking towards the north. Okay, and correspondingly we are going to mark a line parallel to the trough compass when the indicator in the trough compass directs towards the exactly 00 of north south direction. Okay, so when it is bisecting towards 00, I am going to tight the wing nut. Okay, so here you can see it is 0 on north south. Okay, so I have tightened the wing nut and I'm going to draw a line just parallel to the trough compass. Okay, so it is 00, you can see it clearly. Okay, so I draw a north line. Okay, draw the arrow and name it as north. Okay, then further, now the temporary adjustments are being carried out, and now we are going to start doing the bisection. Okay, so with the help of the alidade, by keeping the eyepiece on our side, okay, So the person carrying the ranging rod will be standing at each of the stations which were been marked. Okay, at respect to station A, B, C, D, E. Okay, and we are going to draw the rays. Okay, and name it as it is a graphical representation. We are going to denote small a, small b, c, d, e. Okay, on the drawing sheet. Okay, so here you can see with the help of the LED. So by keeping the fiducial edge in contact with the point O, which is on the drawing sheet, okay, we are going to draw the rays. Okay, so I have drawn the rays from O to B. Correspondingly, for each of the station, I am going to mark the said rays. Okay, so here it is the point C. Okay, then again the person carrying the ranging rod will move to the next point, that is D. Okay, and again I am going to bisect it with the help of the LED and draw the ray. Okay, so we are drawing the ray and not a line. Okay, so basically ray is not having the distance, so we are not right now measure the distance. Okay, and finally at the point E. Okay, I have bisected the point E. Okay, and I have drawn the ray. Okay, on the drawing sheet. Okay, so line is having the distance, whereas ray is not having the distance. So now after drawing the rays, okay, so basic purpose of this is nothing but we can draw the rays and measure the distance parallelly, but you can do randomly. Okay, so A, B, C, D points are been marked here on the drawing sheet. So here you can see here A, B, C, D, E. Okay, and finally, okay, we are going to measure the distance from the station O to the all the objects where we have kept the ranging rods. That is nothing but A, B, C, D, E. Okay, measure the distance. Okay, write it down first of all over the drawing sheet of each and every race. Okay, so this is nothing but 8.8 meter. Here you can see the distance OA, which we have measured with the help of the measuring tape. Again, OB distance we have measured. So that distance is 9.20 meter. Next, OC distance is been measured. Okay, from O to C, that we are going to note it down. So we are going to write down all the distances just above the ray. Okay, then OD distance. So it is coming out to be 7.85 meters. And finally, OE. Okay, finally, OE distance we are going to measure with the help of the measuring tape. So the person who is going to handle the tape should be able to read out the tape reading. Okay, so finally I have noted down the reading of OE, that is coming out to 7.40 meters. Okay, so I have written on the top of all the rays. Okay, then after measuring the distance with the help of the measuring tape, final task is nothing but adopting a suitable scale. Okay, So as the distances are small, I'm going to adopt the scale as 1:50. So that means correspondingly 0.5 centimeter on the drawing sheet will be nothing but 1 meter on the ground. Okay, so I'm going to double it. Okay, that is nothing but, okay, exactly. I'm going to double it. So here it is nothing but I am going to mark the double distance. Okay, so here it is 8.8. So double it will be 17.6 meter, 1:50 scale. Okay, or generally we can call it as refraction factor, that is 1:50. So all I'm going to convert 9.20. It is nothing but converted to scale. It will be nothing but 18.4. Okay, with the help of the regular scale which we use. Okay, and finally OE, we are going to convert it. Okay, and we are going to join all these extreme points which we have converted by a straight line. Okay, if any details are there, suppose any corresponding electric pole is there, okay, any light pole is there, any correspondingly tree is there, so correspondingly we can write down the details at each of the respective points. Okay, so this is nothing but in order to get the concept clear, we have conducted this field procedure. Okay, how the plane table surveying by radiation method is been conducted, only for getting the idea clear. Okay, so basically this method is been adopted as I discussed that whenever all the points are been visible, okay, from a single station point in which we can measure the distance. Okay, so this is nothing but plane table surveying by radiation method. Got it? Okay, so that was nothing but the field procedure of plane table surveying by radiation method. And finally your drawing sheet should look like this. Okay, so in which A, B, C, D, E points were there. We have drawn the rays, drawn the north. Okay, then measure the distance L1, L2, L3, L4, L5, convert it to suitable scale, and plotted or joined the correspondingly end points of the points. Okay, so that is nothing but our plane table surveying by radiation method. Okay, so thank you for watching this video. Okay.